Hi, good afternoon, everyone, and welcome. Welcome to this session. My name is Bill Gibson. I'm a program manager in the Azure SQL database group. And my colleague?
I'm Thorsten Grabs. I'm also a program manager on the Azure SQL database team. And Bill and I have been partners in crime for the last couple of weeks preparing this session, which has been a lot of fun. So we're looking forward to sharing that with you guys.
Yeah, now we've got lots of things to talk about, so let's dive in. First of all, we have to, let's see, just remind you all that evaluations are important, so we'd love to get your feedback on the session itself. So please go ahead and do that. So let's just quickly survey what we're going to talk about this afternoon. We have a jam-packed session. We're going to be going pretty quickly. So I'm going to do a very, very quick sort of 40,000-foot look at Azure SQL database, kind of hoping most of you are familiar with the service, so we won't be dwelling much on the general features of it. Then we're going to talk particularly about the topic of the day, really, which is building SaaS applications and how characteristics of the database platform are particularly suited to that task and that application space. Particularly, we'll be talking about the way we can assist you, particularly now with new things we're doing with developing and managing large groups of databases, which is a characteristic, of course, of SaaS applications. And then handling unpredictable workloads. And that's a kind of a key theme that we're going to keep touching on several times during the session. The sort of unpredictability that comes from not knowing who your customers are, the end user, and quite what the workloads of those people are. So let's dive in. Azure SQL database, then, this is my 40,000-foot view of this. So it's a global, fully managed database as a service. So it's the PaaS model for databases. You're just going to buy and consume databases, create them as you want, when you want. We think of it as being built for SaaS and enterprise applications, so it's built to scale, built to handle a wide range of workloads, and we'll be talking about that as we go. And a key thing that we've introduced, and if you listened to the keynote yesterday, you would have heard about the elastic database model, and we're going to be talking about that today, particularly focusing on that. As a service, it has extraordinary, unprecedented availability, 4 nines availability across the globe, in 17 regions across the globe. And we have tremendous, to back that up, we have a replication model that's a local replication model, but also in case of disaster recovery scenarios, we have a geographic replication between those regions and the ability to restore databases should there be a disaster at any one region. So it's an important characteristic that of an enterprise class service. And the databases themselves are secure, they're protected, and they're compliant with a wide range of international standards. So we've spent a lot of effort making sure this is a platform that you can trust and build solid applications on. And significantly, we've been sort of moving towards this place, but now with a release of full-text search that's happened now in preview, we can now claim that we're fully compatible with SQL Server 2014 databases. So it's a database-level compatibility. So effectively, SQL that you can write to run on premises, you can now run in the cloud. There's tremendous compatibility there. So that's a great story, helping customers with migration scenarios, for example. And throughout the evolution of the platform, of the service, we focus heavily on easy development and easy self-service management. So the fact that you can take over the service, you can manage it and look after it yourself has been a key characteristic of that. And you'll see great evidence of that in the experiences we'll show you this afternoon. And then if we think about the way we deliver the service to you, we deliver it in these service tiers. We have tiers for basic, standard, and premium databases. So you can buy databases in any one of those tiers. They differ. They differ in terms of their target intent. And so their intended use here, basic for light transactional loads, standard, we think of as our go-to tier it's our default tier, in fact, for most business application workloads will be targeted into that space. And then premium for our high-end, high-throughput, business-critical applications. So you can see there, one of the key things that differs between those tiers is the performance, and we'll talk much more about that as we go through. So basic databases have effectively the lowest level of performance, so they have a price that corresponds, and then standard and premium, we offer increasing levels of performance with those. But perhaps what's most interesting about this image is not what's different about the service tiers, but what's the same about them. So significantly, and very relevant to the talk today, we have this sort of model of workload elasticity, and the fact that we can create databases that are at different levels, but also we can create databases in what we've introduced now are elastic database pools. And these, and we'll be talking about these. These pools allow a database to flex and to show great dynamism, if you will, to change its workload very, very rapidly. So it's a new concept, and significantly, we're enabling this across all these tiers. The compatibility and the high availability I mentioned, again, the same across all these tiers. You're not sacrificing any of those features. So our philosophy is very much now that you can build an application once and then scale it as you need across these different service tier offerings and elasticity offerings. So let's give you a taste. We're going to take a look quickly at a demo application that we've built, and that's going to show some of the characteristics of a SaaS application. So we switch over to this. So this is an application, and if you were in the session earlier today, which was a wingtip tickets session, I have to say that very carefully. In fact, I probably will fail several times. So we took that application, which is designed as a global service, and we've turned it into a SaaS application. So we've turned it into an application which could be used by different customers. So think of us as the SaaS provider. We sell it to different companies who are interested, different organizations, in selling tickets. So here we've got a jazz club, might be a small company, that is selling tickets to their customers. I've got another one here. Let's find my mouse. We've got Contoso Concert Hall, and it's just, you know, we look down through here. This is a real application. I can move around in here, and significantly, the data for each of these customers is completely separate. That's, you know, it's a key characteristic of a SaaS application, is that each customer buying this application, buying this service, application as a service from the SaaS vendor, wants their data to be private. We can open up another one of these, and there we go. I've been to this site before. So here's a judo school that's also selling tickets for tournaments that they host, the school here. And, you know, I can come in and I can buy tickets here, and you know, just sort of, actually I need to sign in first before I can do that. So let me sign in and just think about what I'm doing. I'm signing in here as a user of the Dogwood Dojo. I'm not a user of Wingtip Tickets global service. It's not like Ticketmaster or something like that. I'm a private customer, private end user of this particular judo school's application. They value me as a customer. They want my email address. They don't want to share it with anybody else. They want to sell me tickets. They don't want me wandering off into some other site and doing something else, buying tickets for some other event. So it's a private experience that's customized for me, the user, customized by the customer of the Wingtip Tickets platform, the SaaS provider. Right, so I can come in here and I could go ahead and buy tickets. You can see the experience here. I'm not going to go ahead, we don't need to dwell on that. But what I've done, let's switch back to the other here, is basically motivate some qualities then that are important about, let's switch to the next slide, about what I describe as data-intensive SaaS applications. So there are SaaS applications that are not so data-intensive. It wouldn't be so relevant what we're talking about. But ones that are, is this key notion of data isolation and privacy and protection. You know, I don't want anyone breaking out of one customer space, customer data space, and somehow seeing the data from somewhere else. there's this notion of scale, because as a SaaS provider, I want to be able to scale, frankly, to support unlimited customers. I may start today with only 10 or 20 customers. Maybe I just have one customer, but I want to design an application that's going to scale. So that's a key quality that I want. And then we're going to come back to this idea of unpredictable usage. So the Dogwood Dojo and the Contoso Concert Hall, radically different size customers with potentially very different usage patterns. Perhaps one has frequent concerts, the other one has occasional tournaments. Same sort of requirement, but very different profiles of usage. So traditionally, and I say that in a sort of, there's a common pattern of building SaaS applications, multi-customer database applications, is to use a multi-tenant database strategy, to have a large database and put all the customer data into that one database and key it in some way on the customer ID so that all your queries now carefully extract the right customer's data from that database. Now, that's an effective model, and it's certainly one that has worked for many people. But obviously, that's a kind of complicated design. It's a sharding pattern design, because you're still going to run out of space in even the largest databases. But it introduces all sorts of management complexity. What happens if a customer reports an error? You have to go and pick one customer's data out of that multi-tenant database and recover it to some earlier point in time. That's a complex problem to go solve. So why not do it a different way? Why not give each customer a database? So now, instead of having 20, 200, 2,000, 20,000 customers jammed into a small number of databases, why not give them all a database? Well, one reaction to that in the past has been, well, that's an awful lot of databases to manage. And indeed, that's the point that we're really addressing. We're changing the way you can think about managing large numbers of databases. So, but if you can go with, just sort of sustain that thought for a moment, that we're going to solve these problems of database management, then look at this, look at the things that the platform brings you. Because we sell you individual databases, we focus all our attention on managing databases, not managing customers inside a database. So now managing a database, if you give one customer per database, is effectively managing the customers. So if I can monitor and secure and audit interactions with a single database, I'm watching what that customer is doing in their database. As customers come and go, as customers' capacity needs change, those equate to the life cycle of an individual database. I create a database when I need one. If the customer goes quiet, I can take it out of circulation. If I need to scale it up, I can scale it up, and so on. Again, this oops recovery, I can recover an individual database. Now, very easy and very fast, because any one customer's data is typically small. So I can recover a database to some earlier point in time. Another cool thing about this, from a development standpoint, is the schema is unchanged by this. So it doesn't matter how many customers you have, you just write the schema for a single customer and let other parts of the system handle the scale. So I talked about providing tools that are going to assist in this process. So things we're doing now, that we're adding to the sort of panoply of tools. Obviously, we've got management tools in the form of the Azure portal, for example, but also we're adding facility for cross-database query, for reporting, analytics, and data integration, allowing you to move data between databases. So now you'll be able to run a query across a large number of databases, and we'll see that in a moment. Also running jobs across large numbers of databases. And then you can connect with the traditional set of tools. There's no difference here. These are, especially now that we've ensured the database compatibility with SQL Server 2014, all the tools you're familiar with, the programming experiences, database programming experiences you're familiar with, all apply now to these databases. There's nothing special. They're just individual databases. OK, so if we take a look at the application, the architecture of Wingtip tickets, the SaaS application, this is the architecture we've implemented. And this really is what we've built here. So it's a cloud service. It's scalable. You connect to it through customer-specific endpoints. And then we use a system to route you to the correct database based on the customer identity. So as you identify yourself, you come in here and we do that routing. And in fact, that's the first of several challenges that we're going to talk to as we go through here. So I'm going to hand over to Torsten, and you pick it up here.
Thank you, Bill. So basically looking at this picture, one of the first challenges that you're probably going to realize soon is as a customer connects to their endpoint, we've chosen Traffic Manager to implement these endpoints through different URLs, but you could choose different approaches as well. Now imagine a customer and their end users are starting to use that endpoint that we have provisioned. So the requests are coming into our cloud service. We need to find out what's the corresponding database in the data tier that we need to route that request to, and we need to broker the appropriate connection. The way that we do that is we basically keep the mapping information that maps the requests that come in through the URL to the corresponding databases. We store that in a catalog database, and I'll explain in a minute how we are actually doing that. And based on that, then we have the information that allows us to get the connection into the right database for that tenant. So that's kind of the first challenge that we have to deal with that most, or if not all, SaaS providers have to deal with when they're using multiple databases. And you can obviously go ahead and write all that code yourself, implement basically the mapping store, keep track of all of the databases that participate in your data tier. You can implement that yourself. However, we are providing you a lot of help with the Elastic Database tools. It includes a set of libraries that's specifically targeted at this problem. The first one is basically having a data tier that comprises many, many databases. How do I define that set or group of databases? And then how do I store how customers or tenants are being mapped to individual databases? So that's the multi-database management aspect that we're covering with the libraries in Elastic Database tools. And the second aspect then goes back to the challenge that I just described, using the information about the different databases and the mapping of customers to databases. How do you efficiently broker connections for incoming requests to the right databases? And that's another key aspect in those libraries. And what I want to call out specifically is you can imagine that every incoming request does a round trip into the catalog database to basically find the mapping. That can at some point become very inefficient. That database can become a bottleneck. So we have paid a lot of attention to make sure that we have a very effective caching scheme in place so that you, in most cases, avoid an actual round trip into the catalog database. And that's also included as part of the libraries. And we're very excited this week to announce that we have made these libraries generally available. And we hope that gives you a lot of confidence using these libraries for your applications. They're fairly approachable, fairly easy to find. So if you go into NuGet in Visual Studio in the package manager and search for Elastic Scale, you will find them immediately. And it's basically a set of client libraries and NuGet package that you can download there. So what I want to do next is basically walk you through an example of scaling out the data tier of our application by adding a new demo customer into the mix, and then illustrating how this data-dependent routing, that connection brokering, works through our Elastic Database tool libraries. So let's go ahead with that. And just give me a second to switch over.
There you go.
Okay, so what I've done is I've put together a PowerShell script that basically abstracts the most important steps. And the first one is basically just a parameter. So we're going to create a new customer that's called Demo Concert Hall. On the database for it is going to be provisioned on this server here. This is our catalog database. This is the actual cloud service URL in Azure behind it. And then I need a bunch of credentials. Let me put that in real quick. There we go. And then you see the rest of the steps. We're going to walk through those. So the first one is the one that's going to take a little bit longer. And that's basically calling another PowerShell script that takes care of creating the underlying database for the customer in Azure SQL DB on that server that we have seen. It will also take initial steps to populate that database with the schema that we are expecting our customers or tenants to have in our SaaS application. So that's also abstracted behind this call that I'm making here. All of this is using standard PowerShell interfaces to Azure SQL DB to create the database in the first place, but also then to run the SQL statements on that newly created database that provisions the schema, provisions the table for our application. And while we're waiting for that database to get created, the next step that you already see here, there it finished. So we have a new database. The next step is basically taking that database and registering it in the customer catalog as a new customer, as a new database that soon incoming requests can get routed to. So let's run this statement as well. And that, behind the scenes, uses PowerShell.NET integration to call into our Elastic Scale libraries to add the new database into what we call the shard map, the catalog, and also register the mapping of the new tenant and its ID to that database that we have just provisioned. Let's put in some data into the tables. Right? And the last step is, let's put a URL through Traffic Manager on top of that. You see, we have demo console hall.wtp.trafficmanager.net provisioned for us. So with that, everything should be in place.
So I should be able to use that now, shouldn't I?
Yeah, let me first go into Visual Studio here and connect to the debugger to our running cloud service. So hang on for a second. So here is the cloud service that's implementing our SaaS application. Let's attach the debugger. Okay, let's wait for all the symbols to load. And you see I have set a breakpoint in an interesting place. Let's switch it over to Bill for just a minute.
Okay, so what I'm going to do is basically connect to that customer. I'm going to type in the URL. So we use a very simple scheme here. We use the name of the customers, the name of the database, the name of the URL. So I'm going to go ahead and connect to that. And so that's me sending off the request.
And you see that the request hangs for an obvious reason. We hit the breakpoint in the debugger on that statement here. And now let me explain what's actually happening with this statement. So I have a class or a namespace SaaS sharding that has a static class, basically a singleton for the mapping and the customer catalog, and that's this customer shard map that I'm hovering over right now. And that is using our Elastic database libraries. And the libraries expose a call that is called open connection for key, which returns a regular ADO.NET SQL connection, but it uses the tenant ID or the customer identity, if you want, as an input parameter to identify what is the correct database that this connection should get routed to. And all of that is done basically on the information that you have provided about the mappings of your customers to the underlying databases. That's stored and abstracted behind that customer shard map object that you see here. And then as we execute this, we're going to open a regular SQL connection, and you see from that point on, it's just regular AD.NET SQL command.
Do you want to switch back to me here? And
Let me run this here real quick. And
we should see this guy should now return. Hit F5 over there. There we go. And so what we've got actually is a customized experience here for a brand new customer. Obviously, as a customer, if I'd called in to Wingtip Tickets and Torsten had done this provisioning job, my problem now would be about, okay, let's now go and customize this. Let's go and set up events and concerts. So this is what I'm seeing, the experience for a new customer. So that's why it's different from the experience that an existing customer has. So there we go. That's the That's the routing story. And what was cool, if you think about it, is all the magic happened in one statement. There was one line you inject into your application there. Instead of creating a normal connection, you create this connection through the magic of this routing system that we've got.
It's a fairly mechanical change. So if you have an existing application, existing piece of code that just calls a regular SQL connection constructor and then open call on the connection, it's fairly easy to change that code and use the new libraries.
Okay, back to this guy. Yeah. Okay, so that was the demo there. So the next challenge we want to talk about is this notion of predictable performance levels. So I talked about the case of different sized companies. The Dogwood Dojo, small judo school, compared to the Contoso Concert Hall, perhaps compared to other companies of different sizes. And this kind of sense that I can predict that it's going to be a busier, the Contoso Concert Hall will be busier, there'll be more ticket purchases, it's a larger concert hall, they have more concerts than the dojo has judo events. So I can sort of predict that I want to have different performance levels. So there's a certain amount of predictability, and there's a certain amount, especially when you're starting out, where you can get the hang of what's going on and you can manage this. And so let's talk about performance. So here I've got the idea that the arrow sizes there reflect the sort of volume of workload that's coming in to each of those different customers, different customer databases. But before we can talk about performance, I need to share a kind of concept with you. I need to share the way we think about performance on databases in the cloud. So we've introduced this notion of a database throughput unit. You can think of this as horsepower for databases, how much oomph you kind of put behind a database. And this unit is actually a measure of relative measure of performance on 4 dimensions. So there are these 4 dimensions here, that of the amount of memory, the amount of write I/O, log I/O, the amount of compute CPU power, and then the amount of read capacity that we offer, read I/O capacity. And it's a relative measure. We don't publish absolute numbers for these because we, as a platform provider ourselves, reserve the right to adjust the hardware, adjust the performance, and frankly, to upgrade the specification of our service over time. So this isn't, but what we do is publish this as a relative measure to help you understand the relative performance of different levels in the service. But if we look at any one database, we can think of, well, how much of that does it use here? So we can think of a DTU meter here. And so if I have a database struggling along here using some amount of that, then I might have a workload that extends and uses more of the memory than the other dimensions there. And you can see that we measure the DTU consume, the database throughput unit sort of consumption, as the largest of the dimensions at any moment in time. So in terms of what is it you're using most of at the moment, that is your sort of, you think of that as the amount of horsepower you need at this moment. So if we change the size of this, you can see that one is out on a different axis, but out the same amount, so it's still 20. This guy has grown overall, and so we think of this as 30 DTUs. And this guy is kind of gone off to the side here, but he's further out, so that's 40 DTUs. So this perhaps is a box that's sized at 50 DTUs. And that's the point. The box represents an amount of capacity we're offering to your database. So you provision a database and can assign to it an amount of capacity. So if we look at this sort of notion of predictable performance levels, you can see that we have, and I mentioned the scaling performance across basic, standard, and premium. We have this range of performance levels, pricing tiers they correspond to. And if we just sort of watch a database, I can scale a database up through any one of these, up and down. And so as I predict the need, or I see the need for more performance, I can scale the database to accommodate that. So if I see that a particular, perhaps I'm being told that by a customer that they'd like to have more performance, perhaps we know some top artist is coming to some small jazz club to play an unplugged session, I can anticipate more demand and give that database more capacity. And I can do that in a sort of predictable way. So how do we do that? Well, there are this is actually not new, so I'm not going to go and do a demo of this. We're going to talk more about the Elastic story in a second. But if I use the portal, I've got a range of these are pricing cards, which basically allow me to pick the different performance levels. Or I can do this in code. I can use T-SQL. I can connect to the master database and issue a query there. I can modify the addition here. I can do the same through PowerShell. There's a PowerShell script for doing this. And we have a REST API. Indeed, all of these mechanisms, the portal and these T-SQL and the PowerShell, all end up calling the same APIs. So there's no difference in the behavior. If you issue a T-SQL, we pick that up and route it back through our management service and operate on the database in the same way. So there's a range of APIs, range of PowerShell features then for managing scaling, which is super.
And is my database going to be available when I change this?
Oh, there is indeed. Yes, great straight man there, great question. So that's scaling. A couple of things about the scaling action is that, why am I getting back? Let's go, stay where we were here. The scaling action, the database stays online throughout the change. The changes typically aren't instantaneous. There can be some period of time. So this is why we say you should think about predicting performance needs. And scaling them in anticipation of that. So if we look here at what this means, we can think about scaling the databases then to support the different loads on each database. Okay, so that was kind of easy enough. And when we're small as a SaaS company, I can maybe manage a small number of databases that way. But you can see how that would get increasingly complicated to try and predict the workload needs of, it's okay for maybe 20 customers, maybe 100 customers, but gets to be a bit more problematic if you've got thousands of customers. Now, we have got systems, you can write scripts and use our APIs to write controlling software that would, for example, detect workload changes and would scale for you. So you can take these actions because the whole service is programmable. So you can kind of accommodate that, but you've got to work kind of at that problem. So what about a different way of solving this when we've got hundreds or thousands of databases? So this is where we introduce the elastic database model. So the elastic database model introduces the idea of elastic databases and an elastic database pool. So this is the notion of providing a pool of resources that can be shared among many databases. Particularly appropriate for databases that are not active all the time. I mean, people aren't buying buying tickets to concerts every second of every day. You may have bursts of activity, but the database is not going to be used all the time by all those customers. So we've got all sorts of opportunity to time slice the interactions to basically share the resources instead of giving each customer resources and with the danger of over-provisioning for some or under-provisioning others and basically not being able to balance my costs as the SaaS provider. What if I can do a better job of predicting the use in aggregate of a set of databases? So that's what the elastic database model is all about. So we're introducing, and this goes into public preview at this conference. We announced it, and it's now available for use. And indeed, we're using it. And indeed, the demo application is running against a pool of databases that you've seen here. We have started with, in the preview, with just the standard Elastic database and the standard Elastic database pool. So that is the tier, and that corresponds to the range of performance available to an ordinary standard database. So it ranges between 10 DTUs and 100 DTUs. So that's what's available. We have a pool then with pool sizes ranging between 200 and 1,200 DTUs. So you can put a large number of databases in there. We currently have a limit of 100 databases, but these are just sort of like getting started limits we've put in place. We will have smaller pools and much larger pools, and there will be more pool sizes in between for scaling the pool itself in a more granular fashion. And again, you can create and configure the pool through various means, through PowerShell, REST APIs, and through the portal, and I'll show you that in just a second. And then you can move databases in and out. Again, databases remain online throughout, whether you're moving them in or out or between pools. And then we've got monitoring and alerting facilities. So you can, in the same way today, you can monitor and alert the performance, be alerted on changes to the performance of an individual database. You can now get the same experience across the pool itself. So let's go take, actually before we do that, just illustrate a couple of points here. One is the idea of the database burst level. So I mentioned that the pool itself supports databases. A standard pool supports the same range of performance as a standard database, so from 10 through 100 DTUs. So effectively, you've got a burst level. It's a max. So if these boxes now represent, each box is scaled to be the height of the pool, 200, 400, 800, and 1200, which are the initial pool size offerings, then you can see how individual databases aren't going to get to burst all the way up to 1200 DTUs, but they get to burst to this standard level. But what can I do with this is I can now put into this a large number of databases. As you can see quite clearly, I could put many more databases into a larger pool. And that's the key to this, is having support for large numbers of databases. And we hope to dramatically grow by potentially orders of magnitude the size of pools that we support there. So sort of watch this space on that one. So from our architecture standpoint, what does this mean? It means we can put databases into pools. We can group them together, give them shared resources. The pools can be of different sizes, different types. I can give different bursting characteristics to different databases in each of those pools. And I can now support, and in this way I can scale out to support the performance requirements of a large number of databases. But critical here is this bursting ability between effectively 0 and 100 DTUs is now available to every single database. So I haven't got to worry about scaling the databases up and down somewhere between an S0, an S1, or an S2, or an S3. I just say they're in the pool, and now they get to scale up and down. I've got more efficient DTU usage because each database that's inactive isn't using the database, so that the capacity that might have been reserved for that is now available for other databases to use, and I've got this bursting ability. Okay, so let's take a look at this. If you could switch over to my. So what we're here, I'm in the portal, and I'm going to do most of this demonstration in the portal because the portal is just a great way, especially when you're handling large numbers of databases. It's a great way you switch from managing many databases to managing a fewer number of pools. It's a great place that you'll be able to operate on these. So here's a server which has got associated with it a set of databases. So I can see here, these are the databases that correspond to the different clubs and theaters that have signed up for our service. So I'm going to go ahead and add a pool. I'm happy to. So I'm doing this. I said that the service was running in a pool already. It is. I'm just got another server set up with the same databases. I'm going to show you how pool creation works. So let's just do that. So I'm in the process of adding a pool. It's a preview, so I have to accept the terms. That's been done already. We only support one tier at the moment. That's the standard tier. So I'm going to go ahead and add the databases. And we're using an advisor, which is going to actually analyze the set of databases and analyze their usage profile and recommend a pool to be composed of appropriately sized databases. So databases that are bursting beyond, are currently active beyond the level of 100 DTUs wouldn't be good candidates because they would be capped, nor would databases that have a sort of constant usage profile. So if a database was being hammered all the time, that wouldn't be a good candidate to put into a pool. You want to use databases that have this ad hoc kind of usage profile. So let's go ahead and select the ones that's recommended, and it's actually recommended every database in our architecture here on our customer server, because that's the characteristic of our workload, that they're infrequently used, as I've been saying. And it's also recommended a pool size, which actually is our default pool size here. And and for the first time in weeks. So maybe just close this and see if we can encourage this to. We have.
Did you select all databases?
Sorry?
Do you have all databases?
Yeah. Right, so rather sadly, one of our graphs hasn't shown up. I'll describe what you would have seen. So we have two basically scales here, two adjustments we can make to a pool. We can change the size of the pool, so I can scale the database here up and down, the pool size up and down. It's rescaling the axis there as I hit these higher levels. and I can adjust the amount of that capacity given to each database. So we use the same amount for every database here. And currently it's set to 100, but you can see what we've got scaled here is the peak and average DTUs that have been analyzed over the last 15 to 30 days of the databases that we're thinking of putting into this pool. And it's basically showing me how much, in the DTU meter, how many DTUs they've been using. So it's looking at a historical performance and saying, okay, so if I were to, for example, reduce the bursting from 100 down to 50, you can see we would actually cap some of those databases. Some of their peaks would now not be allowed. And by not be allowed, I mean they would actually be slowed down. That's what would happen. Nothing would be terminated. There'd be no connection loss. It would just slow down the performance to that level. So we probably would. A key point to bear in mind, though, is to think about what is it that's going on. You may be happy to have some less important queries capped for the sake of allowing more databases to have more capacity, to burst more freely. Obviously, a database that bursts higher is using capacity that isn't now available whilst it's bursting for other databases. So it's a kind of tuning measure that you've got there, tuning option. You can also set a minimum. Let's go back to 100 here. A minimum DTU, and this would be actually reserving DTUs, reserving capacity for databases. And as soon as you start doing that, you effectively start decreasing the number of databases that are allowed. So if I had that at 0, we actually have right now a system limit of 100 databases per pool. But you can see if I up that to 10, that limit comes down to 20. And that's very simple. It's the 200 DTUs divided by 10. So to guarantee every database can get 10 DTUs, you can only have 20 databases in that pool. So this is an option. It's not one we think will be used by many people very often. Most people are going to have a profile that suggests they want to be able to just allow the databases to come and go and to use 0, have no capacity reserved for them when they're not active. But it depends entirely on you and your requirements. So then I could go ahead and accept that. Oh, let me tell you what you didn't see, which you will see when you use the service, is in this upper space here, we actually plot on there the aggregate usage and the aggregate storage of the databases in the pool that you're proposing to put into the pool. So we actually aggregate. Basically, we're looking to see if we were to run the databases you've picked, if they were to have been in the pool for the last month, how much capacity would they have needed? And what you would have seen is a graph and a growing trend line of storage space here, indicating that 200 DTUs was well sized. It was a good recommendation. And you would see that if you scaled it up to 400, you would have had masses of headroom. So this is a good way for you to choose the size of pool and the amount of headroom you want to have. So you go ahead and select, and we would select OK here. And this is going to take us back to the start board, and it will put up the elastic pool here, so I can now, it'll create the pool, and once it's created the pool, it'll start moving the databases into the pool. Each database remains with its current service tier and pricing and performance level until it lands in the pool, and then it's subject to the performance of the pool. Okay, now, like any good cookery show, I have one of these created already, so we take a quick look at the pool that we're using for the demo itself. And wait while this loads. So we've got the same graph information here about the historical performance. So these are the same databases running the same test loads against them. So we see the same performance profile. And what this is telling me here,
there it is.
There it is. Oh, indeed, that's the kind of shaped graph we would have seen. So we are running a workload against these databases. We open up and see the list of databases, and go and open any one of these here. We can open and see the individual workload. So we're running a test workload against these. We don't actually have people buying tickets for our fictitious. And you can see that there's a periodic, basically it comes in, we buy a bunch of tickets, and then we go off. And each database has got a different timed kind of pattern here that's going on. And you can see here we've got the graph then showing us, and we'd have seen a similar graph in the earlier display showing the anticipated utilization. And in the way that you could set this up beforehand, we can come in here and we can scale now the same the same qualities. We can scale the size of the pool, and we can scale the maximum and minimum per database to optimize the pool for your current workload. Also from here, you can, if we go back to this databases list, you can add and remove databases from the pool from here. So you can go and add databases to the pool that are on the server, but not yet in the pool. Okay, so in the interest of time, I think I'll skip that last piece. Let's go on and go back to the slide here.
Okay.
Okay.
You want to move
to
the next slide?
So so we've talked about handling sort of this unpredictable workload zone. So this unpredictability then matches well to the notion of this elastic pool. But every now and then we have the need, even with a pool, for a particular intense workload. So how would we handle that? Well, of course, the two models are complementary, the notion of elastic databases and normal databases with their individually scaled performance. So what we can do is, if we now predict or see that there's a intense workload requirement, we can take a database out of the pool, we can scale it up, it can survive in this, can stay as long as it likes in this state of being outside of the pool, of being assigned the performance that it needs to get the job done, and as that workload kind of quiesces on that, and we see that we don't need that. So perhaps this was the unplugged concept of the Rockstar here, and then we can bring it back down to size and drop it in. In fact, you can drop it straight back into the pool, and it will now adjust itself to the characteristics of the pool. Let's actually go on and talk about this guy here.
Okay. So we've seen how you can put lots of databases in the pool and how you can very effectively manage their performance characteristics, their capacity, their resources. As a SaaS provider with lots of databases, the next obvious challenge you will run into is querying across that set of databases in your data tier. So imagine you have tens or hundreds of databases, how complicated it would be to manage the different connection strings individually, to open up the connections programmatically or through a script, and then putting all the results together in one place. So to address these challenges, we announced earlier in the keynote on Wednesday Elastic Database Queries, which gives you the ability to connect into a single Azure SQL DB database and register an underlying set of databases, the customer databases in this picture here, register that as a set of databases that you can query through a single SQL statement from a single database connection. And I'm illustrating this single database as the Elastic Query database that's living off to the left of the customer databases. And since it's a single and just regular SQL Server database, you can use all your familiar tools and programming paradigms to connect to that Elastic Database Query database, and then use SQL to transparently query across your data tier with tens, hundreds, or maybe even thousands of databases. So let me tell you a little bit more about this. I mentioned a lot of these points already when talking to the previous slide. One key aspect to keep in mind, and we'll see that in the demo in just a minute, is that it leverages the capabilities that we saw in the first demo that I showed, where you were using the Elastic Database tools, the libraries, to store the set of databases and to keep the mappings of tenants and customers to these different databases. So Elastic Database Query leverages that information that we stored in that customer catalog database. It leverages that and can then, by virtue of doing that, knows what's the set of databases that queries should stretch over. It's a very straightforward, very simple experience. The setup is basically just two different new DDL statements that we're introducing into T-SQL. And from that point on, it's just regular T-SQL queries against what looks like tables, but what is essentially a view over databases that are physically stored and scaled out across your data tier. So let me show you that in action. Let's jump back into Visual Studio. And what you see here is, let me start by first illustrating the DDL statements that you would need to run. And I have done that on the database that we are connected to, the Elastic Query database. I've already done that previously. The first one is the creation of what we call an external data source. And its parameters are basically taking the information about the customer catalog and the metadata that the libraries use to do the connection brokering for us. And that is essentially what you see here. And there's a view that we can use. And let me bring up the results. And we have one that has been pre-provisioned. It's this guy down here. We've given it a name. And that's our external data source. And we are using that then in these statements that you see here that are creating external tables. And these external tables, they look and behave like regular tables, but they don't hold actual data physically in the database where they're created. They're basically just a shell on top of the data that's living physically distributed in the databases in the underlying data tier. And they know about these databases because they're referring to that external data source that we just created in the previous DDL statement. And what I've done in this example here is I've created one table, customer configuration. That's one of the tables in the application that lives in the data tier. And here's the second one, country. And I'll not run this. Let me run a few simple queries on top of that. Here's one example going against the external table customer configuration. And let's run this. It takes a second or so. And what the query is basically doing, it's showing for us the styles or themes that our customers of the SaaS application have chosen for their websites. Let me make this a little bit larger. So you see that we have a lot of fans of jazz and a lot of theater fans as well. So that's kind of the distribution information that we can pull very easily, and that can be very, very important information for me as a SaaS provider to see what's the behavior of my customer, what are the interests, and I can do that with just a simple single SQL statement. Here is very similar information about what countries we are supporting for our customers in that SaaS application. Right now, we are very limited in by just supporting the United States. We'll just change that in a second, right?
Let's see if we can fix that.
We're both not from the States, so that looks odd, right?
It does.
So that basically gives you a quick view into Elastic database queries. The key takeaways are you're connecting into a single database, you're using regular T-SQL, but what essentially happens for you behind the scenes is that the query runs across tens or hundreds of databases, and Azure SQL DB is doing the heavy lifting for you for the distributed processing that needs to happen for that. Now, we talked about queries, and obviously the focus for queries is an interactive scenario. I come in with a T-SQL query that I want to run right away, or I'm using a report. You can use Power BI and connect to that Elastic Query database to run reports. There's another scenario that is a little different. That's typically in a batch context with administrative tasks or operational tasks. Imagine that in the life cycle of your application, and every SaaS provider is going to hit that as they evolve their application over time, you have to make schema changes, or you have to roll out additional reference data, provision new user accounts, or rotate the administrator password. So the challenge that you're facing is there's a piece of T-SQL that I need to run against each and every database in my pool or in the set of customer databases for my application. And what we also showed as part of the keynote and that we started in preview this week is what we call Elastic Database Jobs, a capability that allows you to submit a T-SQL statement against a pool, an Elastic Database pool, and have Azure SQL DB take care of running that statement across your set of databases. And you could think, hey, I can do this with a for each loop in PowerShell as well. But there are a couple of key additional capabilities that you get with Elastic Database Jobs. So for instance, if you're hitting transient failures for some of the databases along the way as you roll out that T-SQL statement, Elastic Database Jobs will automatically retry your T-SQL scripts against those databases in the presence of transient failures. And let me show you this in action in the demo. And let's switch over. Oh, I didn't go to the slides, so you didn't see the nice slides for that. That's too bad. So you should have called me out on that. You're also well behaved. So let me jump into the portal. Here is the Elastic pool that we are using for our SaaS application. And up here, you see the experience to create jobs. And let's create a job like this to roll out reference data. And here you see that we're fixing the problem that we're limited to the United States. Bill is from the UK, I'm from Germany, so let's add those countries here. And it's just a T-SQL statement. Let's submit this against the pool and see what happens.
So where's it running this job now?
So this job is basically running in a cloud service that you have provisioned against your subscription and that you manage yourself at this point. But it's tightly integrated with the portal. So as soon as you go through the provisioning experience for these cloud services, then they basically snap to the Elastic database pools that you have shown. So let's look at the job and what has happened to it. This is the one that we just created, and you can see it's already completed. And you see that it ran successfully against all of these databases. Now, since we have global query, we can actually, or Elastic database query, we can actually check this out and see whether that's true and the job has really run. So let's run this SQL statement again and see what countries we have. And yes, very much indeed, here they are.
So the counts there, the counts of databases that have
that's the
those
count
countries,
of databases.
those countries present.
Yep.
So all the databases, all 32 databases
Yep.
landed with that change being made
Yep.
on them. Awesome.
Okay, so with that, let me jump back to that slide that you missed, which is this one, just to illustrate the capability that we just have seen, basically Elastic database jobs rolling out that T-SQL statement across your database pool. Okay, so with that, I want to hand it back to
Yeah,
Bill.
well, let's just wrap up here. So let's just summarize and remind ourselves of key things here. So obviously we're talking about Azure SQL Database, our global database as a service. And you've seen today our ability to target predictable workloads, and then most specifically and interestingly today, we've been seeing and talking about this use of support for unpredictable workloads with our Elastic database model here, the use of Elastic databases in Elastic database pools, this pooling story. And throughout this, I think to remind ourselves is that, in a sense, nothing's changed about the underlying database. The databases are still SQL databases. They're fully compatible with SQL Server 2014 databases. So the same T-SQL will execute there. You can use the same tools, the same development experience, the same connection and management technologies and platforms. And then this simple self-service management. And you saw me doing various things in the management portal, backed at every stage by programmable APIs, PowerShell commandlets, as well as the portal operations then. So that's the platform, that's the story. Thank you very much for your attention this afternoon. What we'd love to do is invite you to try this out, to get started. Those of you who are building SaaS applications, to build them on this platform, to exploit this technology, and just try out these new Elastic features here that we've been talking about. And we're happy to take questions. Looks like there's a gang of people coming to the front here. And just don't forget some resources here, so you can connect to these here to go work through these, and then please complete your evaluation for the session. We'd love to hear what you think about this. What you'd love to hear, of course, about what you think about the technology. So thank you very much.